What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Wireless networking. This plays a crucial role in modern IT infrastructure, requiring professionals to understand and configure wireless devices and technologies effectively. And the CompTIA Network Plus exam objective 2.3 covers selecting and configuring wireless devices and technologies in various scenarios. And in this video, we're going to explore key aspects such as frequency options, network types, authentication, encryption, and other critical configurations for setting up wireless networks. All right, so let's begin with talking about channels and wireless networking. So wireless channels, they determine how much data can be transmitted over a network, and channel width, this defines the bandwidth available for communication, which is commonly set at 20 megahertz, 40 megahertz, 80 megahertz, or even 160 megahertz. And wider channels, they offer higher throughput, but can lead to interference, especially in congested environments. Then we have what are called non-overlapping channels. So to reduce interference, non-overlapping channels, they must be used strategically. In the 2.4 gigahertz band, there are 3 non-overlapping channels, which are channels 1, 6, and 11. And in the 5 gigahertz and 6 gigahertz bands, there are more channels available, which reduces congestion and improves performance. All right, so let's talk about the regulatory impacts such as 802.11h. So the IEEE 802.11h standard, this addresses regulatory requirements, particularly for dynamic frequency selection and transmit power control. In DFS, this allows devices to detect radar signals and switch channels automatically, preventing interference. And TPC, this regulates power output, ensuring compliance and regional restrictions. All right, so let's move on and talk about frequency options. So we have the 2.4 gigahertz band, and this is widely used due to its range and compatibility. However, it is prone to interference from devices like microwaves and Bluetooth equipment, and it does support lower data rates, but provides better coverage. And then we have the 5 gigahertz band, and this offers higher speeds and more available channels, reducing interference. And it does support wider channels like 40 megahertz, 80, and 160 megahertz, making it ideal for high performance applications. And then we have the 6 gigahertz band. And the 6 gigahertz band, this is a part of Wi-Fi 6E, and it offers even more channels with less interference. And this band improves throughput and reduces congestion in enterprise environments. And then we have a concept called band steering, and this encourages devices to connect to the best available frequency band, improving performance. And it automatically directs dual band and tri-band clients to the 5 gigahertz or 6 gigahertz band instead of the overcrowded 2.4 gigahertz band. All right, so let's move on and talk about the SSID, or the service set identifier. And the first one we're going to talk about is called the basic service set identifier. And this is the MAC address of a wireless access point in a network. And each access point has a unique BSSID, allowing devices to identify and connect to a specific access point. Then we have what is called the extended service set identifier. And the ESSID, this is a group of multiple access points configured under the same SSID, allowing seamless roaming between access points in larger networks. And it provides network continuity and enhanced coverage. All right, moving on, we're going to talk about network types. And the first one we're going to talk about is a mesh network. So mesh networks, they use multiple access points to provide wide coverage, and nodes that communicate dynamically, ensuring continuous connectivity even if one access point fails. Then we have what is called an ad hoc network. And these are peer-to-peer wireless networks where devices communicate directly without an access point. And these networks are temporary, and they are commonly used for quick file transfers or emergency communication. Then we have what is called a point-to-point network. And a point-to-point network, they connect two devices using a dedicated wireless link. They are commonly used for long-distance communication between buildings or remote locations. And then we have what are called infrastructure networks, and they rely on a central access point to facilitate communication between devices. And this is the most common network type in business and home environments. All right, so let's move on and talk about encryption methods. And the first one we're going to talk about is WPA2, or Wi-Fi Protected Access 2. And this is a widely used encryption standard providing strong security through AES, or Advanced Encryption Standard. And it offers robust protection, but it is vulnerable to brute force attacks and key reinstallation attacks, also known as crack. And then we have what is called WPA3. And this enhances security by using simultaneous authentication of equals to prevent offline dictionary attacks, and it improves encryption for public Wi-Fi and strengthens protection for weak passwords. All right, next we have what are called guest networks, and we're going to talk about a captive portal. So a captive portal, this authenticates users before granting access to a guest network. And these portals typically require users to enter login credentials, accept terms of service, or complete a verification process before using the network. Next, we have authentication methods, and we're going to talk about a pre-shared key versus enterprise. So PSK authentication, this is commonly used in home and small business networks where a user enters a shared password to connect. And when it comes to enterprise authentication, this uses 802.1x authentication with a radius server, offering better security and individual user authentication. Next up are wireless antennas, and the first one is called an omnidirectional antenna. So an omnidirectional antenna, this broadcasts signals in all directions, making them suitable for general coverage areas such as offices and homes. And then we have what is called a directional antenna, and this focuses signals in a specific direction, increasing range and performance. And these are commonly used for point-to-point wireless links and extending coverage in targeted areas. All right, and next we have access points. So we're going to talk about autonomous access points and lightweight access points. So an autonomous access point, this operates independently, requiring manual configuration and management. They are ideal for small networks, but can become difficult to manage in larger departments. Then we have what is called a lightweight access point, and this relies on a centralized wireless controller for configuration and management. And these access points are used in enterprise environments for scalability and improved network administration. All right, so in conclusion, understanding how to select and configure wireless devices and technologies is essential for network professionals. And by considering factors like frequency options, network types, encryption, and authentication, IT professionals can design efficient and secure wireless networks. And mastering these concepts will not only help in passing the CompTIA Network Plus exam, but also in real-world networking scenarios. All right, now with all of that being said, let's do some check on learning. So the first question is, which of the following best describes the primary advantage of using 5 gigahertz and 6 gigahertz frequency bands over 2.4 gigahertz in a wireless network? Would it be greater range and better penetration through walls? Would it be higher data transfer speeds and less interference? Would it be compatibility with older devices and greater congestion? Or would it be ability to operate with lower power consumption? And the correct answer is higher data transfer speeds and less interference. So the 5 gigahertz and 6 gigahertz frequency bands, they provide higher data transfer speeds and experience less interference compared to 2.4 gigahertz, which is commonly congested due to shared use with other wireless technologies like Bluetooths and microwaves. However, 5 gigahertz and 6 gigahertz, they have shorter ranges and lower penetration through walls compared to that of the 2.4 gigahertz band. Next question, which of the following is the primary benefit of enabling band steering on a dual band or tri-band wireless access point? Is it improves security by blocking unauthorized devices from connecting? Is it prioritizes voice and video traffic for a smoother experience? Is it directs capable clients to use the 5 gigahertz or 6 gigahertz bands instead of the 2.4 gigahertz? Or is it increases signal strength for all wireless clients by amplifying transmissions? And the correct answer is it directs capable clients to use the 5 gigahertz or 6 gigahertz bands instead of 2.4. So band steering, this is a feature in modern dual band or tri-band access points that encourages clients capable of connecting to 5 or 6 gigahertz to use those bands instead of 2.4. And this reduces congestion in the 2.4 gigahertz band, leading to improved overall network performance. And our final question, which of the following best describes the difference between an omnidirectional antenna and a directional antenna in a wireless network? Is it omnidirectional antennas send signals in all directions, while directional antennas focus signals in a specific direction? Is it omnidirectional antennas require line-of-sight connections, while directional antennas do not? Is it omnidirectional antennas are only used indoors, while directional antennas are used outdoors? Or is it omnidirectional antennas support only 2.4 gigahertz networks, while directional antennas support only 5 gigahertz networks? And the correct answer is omnidirectional antennas. They send signals in all directions, while directional antennas focus signals in a specific direction. So omnidirectional antennas broadcast wireless signals equally in all directions, making them suitable for general coverage in homes, offices, and public spaces. Directional antennas, on the other hand, they focus the signal in a specific direction, which is useful for long distance point-to-point connections or targeted coverage areas.